Hi, I'm James Mackey and welcome to your monthly top tip to bring you into the world of PicoScopes. If you buy a PicoScope or any oscilloscope for that matter, you'll get some probes with the kit. You can plug them into your oscilloscope and then use them to test your board. But there's more to them than that, like this switch or this tiny screw. And what the heck is this little bag of bits for? Well, let's go a little bit back and look at the probe specifications. One of the key things to look for is the bandwidth of your probe, which simply put is the highest frequency it can see without losing any amplitude. You'll need to make sure the one you get has enough bandwidth for your highest test frequency. Although PicoScope and probe kits usually come with a probe equal to or in excess of your scope's maximum bandwidth. You'll only need to check when buying probes on their own. With all the probe kits, you'll get a probe, a detachable ground lead, a spring-loaded hook tip for probing wires, an adjustment tool, a locating sleeve for stable and insulated probing, and a few different coloured cable marker sleeves for identifying your channels. Some of the higher end probes like the P2036 kit will have some extra bits like ground blades or springs, spare tips and hooks, and my favourite little gizmo, a BNC adapter. Now let's connect this to our PicoScope and start probing. Always remember that your probe and everything attached to it is essentially working as a wideband filter. It has a certain amount of capacitance and inductance which will affect your device under test. The vast majority of probes nowadays come with a switch allowing you to add attenuation to your measurement to reduce this loading effect. A ×10 switch is a common attenuation option that reduces the load from the device under the test. And this will improve your frequency response of the probe and getting more accurate results at higher speeds. But remember to set the PicoScope channel to ×10 to make sure the amplitude reading is correct. ×1 probes are still useful though, as ×10 uses attenuation to achieve its high impedance accuracy. It is susceptible to noise as the measured signal amplitude is so low. To combat this, you can use a standard ×1 setting to have a much better signal to noise ratio. As a rule of thumb, aim for ×10 for better frequency response and less probe loading. If the signal is less than a few hundred millivolts, go to ×1 probe setting. Another way to get more accuracy out of your probe is to adjust the low frequency compensation of the probe using this little screw dial on top of the probe. This will help you match your probe to your oscilloscope by compensating for the difference between each scope's input capacitance compared to the probe itself. This is really important when working with high frequency signals, as the faster a signal is, the more impedance there will be, making a nice square wave into a pointy or limp square wave. Some probes may have a high frequency compensation built in and calibrated from factory, making life a little easier. To dial in the low frequency compensation yourself, connect the probe to the calibration tab on the scope or attach it to the SIGGEN AWG input and create a 1 kHz square wave. Now you can twist the compensation screw until your waveform is nice and square with nice sharp corners. Not like this or like this, more like this. Now your probe is all set up, you can start probing away at your PCB. Make sure you ground your probe, as this will be your 0 volts reference point for your measurements, and it will also work as a ground screen to reduce interference being induced into the long cable. You may also need to think about your ground connection type, as a longer ground loop, like using this little ground clip, will have a much larger impedance through all this extra metal than this tiny little ground spring. You can also share the ground across multiple probes if your PicoScope has a non-insulated output, but your ground loop would be very long and have a lot of extra impedance affecting your waveform. Lastly, PicoScope offers a variety of tools to help you with probing alongside the kit you get with your probes. You've probably noticed these throughout the episode. We have the standard 2-footed probe positioner, and we also have different kits of probe and PCB holders like the one you can see here, so be sure to check them out. Now you're sorted with your probes and calibrating them, you can take accurate measurement to the next level.